Bismillahirrahmanirrahim and Assalamu alaikum. Dear students, hope you are doing well. I am again Video. Today we are going to study ionic bond. You remember me? Yes, I am your chemistry teacher Faizullah Umar. Okay, today we are going to study ionic bond. It's not like something James Bond 007 in movies. It's chemistry. So please clear your mind. Okay, let's start our lesson. First of all, let me tell you what's chemical bonding. You know that the attractive force which holds atoms and ions together and stabilizes them by overall loss of energy is known as chemical bonding. In chemical bonding, mostly atoms and ions react with each other and they form molecules or formular units. Okay, so why chemical bonds are formed? Have you ever had a question something like this? Actually, in the universe, everything wants to get in the state of rest. They want to stabilize itself by losing energy. For example, if you throw a stone, what happens? It will come to the ground and it will stay in the state of rest. Okay. For example, when you work, what do you want? Then you want to take some rest. Yes, definite. That's why atoms want to react with each other to get stable form. For example, the oxygen that we inhale that's present in the atmosphere is in the shape of O2, oxygen molecule. Okay, when oxygen atoms are found, they do not want to live in the state of atom because they are very reactive. They have a lot of potential energy because of the electrons rotating in its outermost or valence shell. So what do? They react with each other. One oxygen react with other oxygen atom and they form oxygen molecule. That's why chemical bonds are formed. Okay, our today's lesson is about the ionic bonding. So let's study ionic bonding. Okay, ionic bonding involves the transfer of electrons between atoms. When one atom loses electron and the other atom gains electron, in this case the reaction happens and the bond that's formed is known as ionic bond. You can see over here there were two electrons. One of them was from this one, the purple one, and the other was from the blue one, from atom A and atom B. But this atom has a weak pull and this atom has a strong pull. So what happens? It loses electron and it gets electron. You can see this atom is happy and this atom is a little bit sad. Why? It lost electron. Now it has turned to a positive ion and it has turned to a negative ion. Why? It lost electron and it gains electron. And this atom was electropositive than this one. And this atom was electronegative than this one. You remember from lesson electronegativity and electropositivity. When an atom has a higher electronegativity, it will get electron, and the atom that has a lower electronegativity value will lose electron. Okay, over here we have an example. Example is lithium fluoride. Mostly in the reactions, metals lose electron because metals are more electropositive, and non-metals are more electronegative and they have high affinity for electron. They gain electron. Over here you can see we have lithium and fluorine. Okay, lithium has 3 electrons and fluorine has 9 electrons. You can see this one. This is the valence electron of lithium and these are the valence electron of fluorine. Lithium has 1 electron, its outermost shell. Fluorine has 7 electrons. Fluorine is very electronegative than the lithium. So what happens when they react with each other? Lithium loses this electron for the fluorine. So they form lithium fluoride. Lithium, when loses its electron, it will get positive charge, and fluorine, when it gains electron, it will become negatively charged ion. Lithium will become cation and fluorine will become anion. They form lithium fluoride molecule, or we can say that they form lithium fluoride crystal or the lattices. Let me tell you, let me show you something else. You can see in this picture sodium and chlorine ions. When sodium and chlorine react with each other, we know that the same thing happens. Sodium loses 1 electron and chlorine gains 1 electron. Sodium will become Na plus or positive ion and chlorine will become Cl minus or negative ion. You can see this. So you can see this sodium Na plus ion. The blue balls are sodium and the green balls are chlorine. They are arranged in a lattice shape. One chlorine, sodium, chlorine, sodium, chlorine, sodium in this kind of 3D shape. So we can say that they form a network of ions, positive and negative ions. This shape is known as lattice. Okay, let me show you what is the lattice. A lattice is an ordered array of points describing the arrangement of particles that form a crystal. Okay, you can see that these are the unit cells of the crystal. they're arranged in such a manner that they form a lattice, and at last they form a crystal. We can explain crystal in a 3D shape. We cannot explain a crystal in a 2D shape. Or let me study this part. The unit cell of a crystal is defined by the lattice point. This is the lattice point or the unit cell. The unit cell is the smallest particle of a crystal. For example, for sodium chloride, this is the smallest particle of a crystal. That repeated regularly through translation in 3 dimensions creates the whole crystal. These gets repeated again and again. So at last they form a crystal. Okay, to form a lattice, there is something else. When a lattice is formed, okay, and when a lattice is destroyed, there is some kind of difference of energies. Let me show you. Lattice energy is a type of potential energy that may be defined in 2 ways. Okay, the first one, the lattice energy is the energy required to break apart an ionic solid and convert its component atoms into gaseous ions. Okay, the first type of energy is energy required to break apart an ionic solid. For example, if you have a solid, okay, if you have a solid material, if you want to break it apart into the component or the atoms that it was made from, what can you do? You need some energy. You have to give it heat. You have to give it pressure, energy to break it apart. Okay, so we need to give energy if we want to break apart an ionic solid or a lattice into its components. Okay, in this case, the enthalpy or the energy that will be required will be written in positive form because we will give energy. It is not an exothermic reaction. It's an endothermic reaction. If you want to break a solid into its smaller components, it will be a endothermic reaction. We will give energy. And what's the next lattice energy? The next thing, the lattice energy is the reverse process, meaning it's the energy released when gaseous ions bind to form an ionic solid. Okay, now what happens? When sodium and chlorine in the form of atoms, they react with each other, they emit energy. They will lose energy. In this case, it will be an exothermic reaction, and the value of the lattice energy will be in negative form. When the value of energy is negative form, it will be a exothermic reaction. When it is in a positive form, it will be a endothermic reaction. But remember, students, mostly for a lattice energy, we study as an exothermic reaction. The value will be negative. When we study lattice energy, we study that how atoms combine with each other and they get to a stable state and they lose energy. So when energy that has been lost is known as lattice energy. To form a crystal, or in a simpler way, let me tell you, when atoms react with each other, they form a solid form. They lose energy, and the energy that's lost is known as lattice energy. Okay, here are some values of lattice energies in the following table. It's according to kilojoule per mole. You know that what's kilojoule. Kilojoule is a unit of energy and mole is the unit of matter. Okay, so what happens? Here are some ions: lithium, sodium, potassium, fluorine, chlorine, fluoride, chloride, bromide, and iodide. When lithium reacts with fluorine, okay, it will lose 1036 kilojoule per mole energy. It's a very big amount of energy. When lithium is a kind of electropositive element and fluorine is an electronegative element, when they react with each other, they will lose 1036 kilojoule per mole energy. It's a very big amount of energy. This energy is known as the lattice energy for the lithium fluoride. Okay, same thing. Let me tell you about sodium and chlorine. When sodium and chlorine react with each other and they form sodium chloride crystal, they will lose 787 kilojoule per mole energy. It's a very big amount of energy. And if you want to break 1 mole of sodium into the smaller parts, to the atoms of sodium and chlorine, we will need 747 kilojoule per mole energy again. But over here, it will be in positive form. Okay, well, this was about the lattice energy. Hope you have learned it. Let me tell you something else about the properties of ionic compounds. Ionic compounds are mostly crystals. Students, remember this. They will form mostly crystal solids, and ionic compounds will have very high melting and boiling point. For example, if you take a rock, rocks are mostly made up of salts, and salts are ionic compounds. If you want to melt them, you will need very high amounts of heat and temperature. And the next thing, they are hard and brittle. They are very hard, but if they will break apart totally. They have a brittle property. For example, you cannot mend it according like a metal. You cannot bend it like a metal. It will break. It's brittle. And ionic compounds generally dissolve in water, but they are insoluble in organic solvents. I told you generally, but there are some ionic compounds, some salts as well, that do not dissolve in water, but mostly they will dissolve in water. For example, if you put sodium chloride inside the water, sodium chloride is an ionic compound, it will dissolve, but they will not dissolve in organic solvents. Water is a polar compound, and they can be dissolved in polar solvents or ionic solvents. And the last thing that I'm going to tell you, they conduct electricity when they are dissolved in water, or they can also conduct electricity very little when they are in a molten form, but they will not conduct electricity in a solid form. If you take a rock of sodium chloride and you want to conduct electricity from it, you will not be able to do this. If you want to conduct electricity, you have to put it in the water, so sodium and chlorine will be torn apart into ions, so that's how they will conduct electricity. Okay, students, we have studied about ionic compounds. I hope that it was interesting, and remember that it's not 007 James Bond, it was the ionic bond. If you have any question or suggestion, write in the comment section below, and please don't forget to subscribe our channel and give a thumbs up. See you next time. Goodbye.